Right, so this week we're going to take a look at one way to do trigonometry of an angle, and it's called unit circle trig. If you've done like opposite, adjacent, and hypotenuse, that kind of stuff in geometry, that's a little different than this. It's another way of doing this, but this is called unit circle trig. Right, so we're going to look at that this week. And we'll look at like opposite, adjacent, hypotenuse, those kind of stuff. That's going to be next week. All right, so what we're going to do is start out with this diagram. Right, it's kind of like the diagram I showed you guys in the warm-up that we did. It's just a circle, and I've got axes drawn, x and y axis, and I've labeled the angles kind of going around the circle. 0 is on the positive x, 90 is on the positive y, 180 on the left, 270 at the bottom. Now, notice here, it's not just any circle. This is called a unit circle. I kind of have it labeled up on the board, and we did talk about it last week. But does anybody remember what makes something a unit circle? It has to do with the size of it. Well, look at that circle. Michael, how big is that circle?
360 degrees.
Okay, so that's how many degrees go around it. But like, if you would actually measure the size of it, like describe its like radius or diameter.
One diameter.
One
diameter.
Let me make this a little clearer. So usually, if they put something like that, like off to the side, it's just that part, which would be the
one radius.
The radius. Right. So a unit circle is a circle that has a radius of 1. Every problem we do up until Wednesday is going to use this diagram. Every circle is going to be a circle of radius. Now, you don't have to use 1. You could do radius 2, 3, 4. That's what I'm going to show you on Wednesday. It really doesn't matter what size circle you use. But the easiest way, if you've never done it before, to start out with is a circle with a radius of 1. But we'll come back to that idea that you could use any radius you want in a couple of days. All right, so let's say I gave you an angle of 60 degrees. 60, I'm just estimating, would be about right there. Okay, if 45 is halfway, it's more than halfway. That point right there is where your x and y axis cross. That's not on the circle, right? What's the name of the point where your axes cross? Origin. And what's the coordinates of the origin? Right, so this has a coordinate of 0, 0. We're not really interested in that. What we're interested in is coordinates, but of points that are on the circle, like 0, 90, 180, 270, or even this one that I just drew, 60. So this point right here, it has a coordinate. Right? This, if that's the origin, there's a way you can get to 60 degrees. And the way you get to it is to go over from the origin that much to the right, and you go up that much. So you go to the right a little bit, and then you go up more. What we have to figure out, basically this whole week, is what are x and y. That's what we're trying to figure out. So every angle that you can think of, you can put on that circle somewhere. And there's a way to get to that angle as a coordinate. So let me just write that down. So every angle can be represented as a coordinate. Now, technically, that is true. Every angle can be. But we're only going to work with angles that are multiples of 30 or 45. Could you put 7 degrees on the circle and figure out the coordinate for 7 degrees? You could, but it wouldn't be a nice coordinate to work with. The coordinates that are multiples of 30 and 45 are nicer to work with. Okay. So that's pretty much the whole goal for this week. Figuring out coordinate that connects to an angle. So let's see if we can figure it out for, you don't know how to figure it out for 60 yet. Okay, that one we don't know how to do, and we'll look at that tomorrow. But let's start with 0 degrees. Based on the size of that circle, anyone think they could give me the coordinate to start at the origin and end up at 0 degrees? Yeah. Go. 1, 0, correct. To get to 0 degrees, all you have to do is go right 1, brings you to the edge of the circle, and then don't go up and down at all. So that is always the coordinate for 0 degrees on a unit circle. That never changes. Okay, let's do 90. Okay. Anyone else besides Joe think they can give me the coordinate for 90? Yeah.
0, 1.
Yeah, it's 0, 1. Don't go left and right. All you have to do is go straight up. Right, how about 180? Yeah.
-1, 0.
So that's -1, 0. And 270 is 0, -1. Those 4 angles, 0, 90, 180, and 270, are special angles called the quadrantal angles. The reason they're called quadrantal angles is because they're on the axes, and the axes break up things into quadrants. One thing that's special about them is they all have a 0. Every quadrantal angle has a 0, and it actually has a 1 in it, or a -1. Those are the only numbers you ever have to worry about with those 4 coordinates. 0s, 1s, and -1s. The other angles, like 60 degrees, 60 doesn't have a 0 or a 1 in it. Okay. It has other numbers in it, and it usually ends up being a square root. Okay, so we'll talk more about 60s and 45s tomorrow. All right, so when we are given a problem, like let's say I said to you, I want you to find the coordinate for 3 pi over 2. The first thing you want to do is somehow visualize where 3 pi over 2 is on this circle, right? So changing to degrees might be helpful. Okay. Once you change it to degrees, that's going to give you an idea of where it is. Okay? So that's the first step. Try to visualize as a circle where your angle is. How far around the circle is it? Now, when you're putting it on the circle, you've got to remember angles can be positive or negative. Okay? There's a difference between positive 90 and negative 90. They're different. And the difference is, starting from 0, do you go clockwise or do you go counterclockwise? If I'm asking you to find the coordinate of a positive angle, that's counterclockwise. If I'm asking you to find the coordinate for a negative angle, that's clockwise. So the clockwise and counterclockwise is just something you do at the beginning to put the point on paper, so then you have a picture to look at. Then you got to use that picture to figure out the coordinate. Okay, but the visual, at least at first, is going to be very helpful to try to do it. After a while, you might be able to just say, oh, 180 degrees, I know that's left, I know the coordinate's -1, 0. Okay. But at first, the diagram is going to be helpful. All right, so just to kind of show you guys how that works, I'm going to bring up the same program I used last week when I showed you how to convert between degrees and radians. All right. So this program doesn't give you the coordinate. Right? All it does is tell you how many degrees or radians you've gone around the circle. But I'm just trying to show you that if you go counterclockwise, you get a positive angle. If you were to go clockwise, like that, now you've got a negative. Now, I want to draw that. for a second, right? And I don't really care what the angle is at the moment. All I want you to do is focus on where that red circle is, right? So just kind of look at where it is, remember where it is. And now I'm going to go like this. If you compare where that red circle was before to where it is now, what's the difference? What's that? Pretend like you can't see anything else on that board. All you can see is that red circle. And you're comparing where it is now to where it was before.
Basically the same.
Exactly in the same spot. Right? The direction you took to get to that point is different, but it is in exactly the same spot as it was before. So what that means is this angle, negative 270, and this angle, 90, are the same thing. Because all we're going to care about is where that red circle is. Those two angles that I just mentioned to you both have the same coordinate. They have exactly the same coordinate. It's up. On our circle, it would be up 1. This grid is a little different, but it's the same idea. It's just up 1. So the first one was negative 270. This one was 90. If we can, we're going to want to think about angles as positive versus negative because it's usually easier to deal with that way. So if I'm here and I go like that, what did I just do in terms of arithmetic to the angle? Went like this, but what does that mean I really did in terms of like changing negative 270 into positive 90? Yep. I added 1 revolution to it. Exactly. I added 360. So adding and subtracting 360 gives us a way to take angles that are negative and fix them so that they are positive. Right? Because we don't want to deal with something like that. Negative 540, that's too complicated to think about. You can see where it is because you have a visual. But negative 540 is exactly the same as negative 180. Or even better, the same as positive 180. Okay? So all we're really concerned about is where is this red circle? What would the coordinate be for it? Not how many times you've gone around the circle. We don't care about that at all. Okay? Just where did you stop? So, this idea of adding and subtracting 360 can help you to do 2 things. One, if you have an angle that's too big, it can make it smaller. If I said to you, I want you to tell me where the angle 1080 degrees is. Most people off the top of their head, it's too big. They can't really visualize where 1080 would be. But if you use this trick, subtract as many revolutions as you need to until you make it smaller, it's going to make it very easy to visualize where 1080 is. And I don't need that program to do it. I could just use a calculator. I'm going to subtract 360. I'm going to do it again, and I'm going to do it again. So 1080 is exactly the same as 0 degrees. They're the same thing. And I can show you that by going like this. There's, well, roughly. That's 1080. Look at where it stopped on the server. It's to the right. We've gone around a bunch of times, but we don't care about that. It's to the right. So let's go back as many times as we can and still stop on the right and put it perfect. But that's the same angle. Now, if you subtract 360 too many times, so you started with 1080, I subtracted it a few times, but if you do it too many times, now you're going to get into negative. You don't want to go that far. You only want to subtract 360 as many times as you need to, so that your angle is between 0 and 360. And same idea if it's negative. You can add 360. So if somebody said to me, find the coordinate of negative 3,000 degrees, you've gone around so many times, I can't really visualize where that would be. Right? What I could do is take negative 3,000 and add 360 as many times as I need to till I can finally figure out where that is. 240. Right. That I can visualize where it would be. I know 180 is halfway. I know 270 is 3/4 of the way. So this is a little bit before 3/4 of the way around the circle, which is the same as whatever I started with, negative 3,000 or something. Now, if you were working in radians, 360 is the same as 2 pi. It's harder to add and subtract when you're doing this in radians. So my first suggestion is going to be any problem that they give you. Let's say I said, I want you to find the coordinate for 9 pi over 2. Wow. That's going to be a confusing angle to deal with unless you change it to degrees first. Right? Once you change it to degrees, the way I showed you guys in the warm-up, then it works the same. So it's much easier if you change things to degrees to be able to do the arithmetic. It's not necessary, but it's easier. All right, so what we're going to look at now is how we define the 6 trig functions. Now, every definition that I'm going to give you is going to be based on this. It's going to be based on the fact that you were able to figure out the coordinate. If you can't get the coordinate, then you're not going to be able to do any of these definitions. Okay, so you have to be able to figure out that x and that y value. There's 6 different trig functions. Depending on which one I ask you for, you're going to do something with the x and the y value from the coordinate. And I'm going to show you what you do for each formula. They're very simple formulas. All right, so again, these definitions are based on the fact that you have already figured out the coordinate. All right, so first trig function we're going to look at is sine. Right, so a problem you might see is something like this. Find the sine of 90 degrees. Well, step 1, what's the coordinate? Can't do this unless you can tell me the coordinate for 90 degrees. Okay. Once you have the coordinate, if I ask you for the sine, all you need to tell me is the y value. The sine of an angle is the y value of its coordinate. That's sine. Another trig function we're going to look at is cosine. If I asked you for the cosine of 90 degrees, step 1, find the coordinate. Step 2, tell me the x value. Sine and cosine are the easiest two to do. Because once you have the coordinate, there's no additional math you have to do with them. The other ones there is. All right. So the next one we have is tangent. So if I ask you about tangent, step 1 is going to be, okay, what's the coordinate for whatever angle he's asking me about? And step 2 is going to be to divide the y by the x. That's how you find the tangent. Y divided by x. So we've got division here. And what did we say in the warm-up you're not allowed to leave in the bottom of a fraction? Square roots. So tomorrow, when we start to talk more about the 30 and the 60 angles, which we're not going to get to today, they involve square roots. And the x value could be a square root. And the problem with that is that x is in the bottom. So we will end up with square roots in the bottom that we have to fix. All right. Now, if you look at like this calculator, or pretty much any calculator, you're not going to see these names fully written out. What you're going to see is 3-letter abbreviations. All right, so for sine, the abbreviation you'll see is SIN. Pretty much every trig function uses the first 3 letters as its abbreviation, except one of them that won't work. You'll see why in a second. That one is cosine. And this one is, for tangent, just TAN. Okay. Questions on those abbreviations? Okay. So those are your first 3. Now, the only one that I wrote so far technically as a fraction was tangent, y over x. But if I wanted, I could make each one of these fractions by putting them over what number at the bottom? What number? 1. I don't really want to do that. I don't really want to write that. Just you could pretend like it's over 1. But I'm doing that for a second because I want to show you something on the right. So the next trig function is cosecant. And the reason I wrote them in a table like this, you're going to have 3 rows, 2 columns, is because the ones on the right are just the ones on the left flipped. Okay. So if sine is y over 1, what do you think cosecant is? It's 1 over y. Now, that's going to be the same thing for all of them. Right? The ones on the right, fancy word, it's reciprocal. You take what's on the left, you flip it, and you get the one that's on the right. So sine and cosecant are reciprocals. Cosine and secant are reciprocals. So what do you think the formula for secant is? It's 1 over x. Again, if you're thinking, well, how do you flip x because it's not a fraction? That's where I said in your head you could pretend like there's an imaginary 1, and now you can flip it. And based on that, what do you think the cotangent is? X over y. Now, out of these 6, 4 of them have a, if you think of it like this, 4 of them have a certain number in them, a 1. The only reason that that 1 is there and over here is because of that word right there. 1, well, when we're talking about a unit circle, means it's a circle of radius 1. If you wanted to do a circle of radius 2, you could. And you could pretty much use all of these formulas again, except all your 1s would be 2s. If you did a circle with radius 12, all your 1s would be 12s. For up until Wednesday, we're just going to keep them as 1s because it makes the math easier. But all of these formulas would still work, even if your radius wasn't a 1. We just have to change that. So technically, that is really your radius, which up until Wednesday is going to always be 1. So you don't really need to think about it too much. So we got y, x, y over x, 1 over y, 1 over x, x over y. What do you think the abbreviation is for secant? I guess, based on the abbreviations we've done so far. Yeah. SEC. Wasn't a trick question. Not yet. How about cotangent? What do you think that one is? Well, Kyle, what do you think? COT. Why do you think I saved cosecant for last? Any thought? Yeah. Yeah, why not COS? Right. Cosine and cosecant have the same first 3 letters, so you can't use the same abbreviation. So for cosecant, you just go by the syllables. Cosecant. CSC. Okay, so pretty much from now until the end of the year, anytime that I write a trig function on the board, I'm going to use one of those abbreviations. I already told you guys that earlier. But the angles 0, 90, 180, and 270. Those are quadrantal angles, and I already explained why. All right, so how do we put this together? Like, how do you actually do a problem using the formulas I just gave you? Well, step one, which I keep saying, is find the coordinate. Find the point. Find the location. Okay? Find the coordinate. Find the x value. Find the y value. If they don't give it to you to start with, there are some problems where they'll just give it to you, and then you don't have to worry about finding it. Like in this one. I'm going to go back in a second. But when we do this problem in a minute, I'm telling you the coordinate right away. I'm giving you the x, I'm giving you the y. So you don't have to worry about finding the coordinate. So step one, find the coordinate if you have to. Step two is plug that coordinate into the formulas from the previous page. Which formula do you plug it into? It depends which one they ask for. If they ask for tangent, plug it into tangent. If they ask for secant, plug it into secant. The way we're going to do it in class is we're going to do all six. So for every problem that I give you, we'll do the sine, the cosine, the tangent, cosecant, the secant, and the cotangent. On the test, it won't be set up that way. I'm going to ask you for one per problem. But we're going to practice all six per problem, just to get used to doing them all. Okay, so summarize it. Step one, find the coordinate. Step two, plug it into the formula. Keep in mind your rules for arithmetic. No square roots in the bottom. So if that comes up, we got to deal with it. And before we go to the next problem, I want to go back and look at that diagram real quick again and look at the coordinates that you guys gave me for 0, 90, 180, and 270. But maybe we can remember if you can kind of visualize it in your head. Does anyone remember what was the coordinate for 0 degrees? That was 1, 0. Just going to make a list of them off to the side for a second. And I want you to look at them once we're done. How about the coordinate for 90? That was 0, 1. 180. And 270. Now, take a second and look at all those four coordinates. Just kind of look at what they look like. Now I want to show you the coordinate from the next example. That's the coordinate. -1/2 square root 3 over 2. Does that coordinate look like any of those four? No. So what that means is that coordinate right there is not the coordinate for 0, 90, 180, or 270. What is the coordinate for? Don't worry about it. Doesn't matter. You don't need to know what it's the coordinate. You will by tomorrow. You'll know what that is. But the goal of today is not to know what angle this is. The goal for today is to know the coordinate. That's what you need, and you have it. So don't worry about where this coordinate came from. Okay? You need the coordinate, you have it. If you're really interested with what it is, that's the coordinate for, it's in the second quadrant because it's left and up. It's the coordinate for 120 degrees. Again, the fact that it's the coordinate for 120 degrees, who cares? You have the coordinate, that's all you need to know. So, we're going to use that coordinate to find the 6 trig functions. Now, I know that it's 120 degrees. Maybe if you've had any kind of pre-calculus or trig before, maybe you already knew it was 120 degrees too. But I'm going to guess that 95% of people in here had no clue that that's the coordinate for 120 degrees. So we're going to be figuring out a bunch of things about 120 degrees just by knowing its coordinate. You don't need to know that it's the coordinate for 120 degrees. The same way that if I said, I could describe somebody without knowing their name. Well, how can you describe someone without knowing their name? I don't need their name. I don't need to know their name at all. I can look at somebody and say, what color shirt they're wearing, what color hair they have, what color eyes they have. I don't need to know somebody's name to do any of that. You don't need to know the size of this angle to do anything we're about to do. It's the same idea. I'm going to describe a bunch of things about this angle without ever even really knowing that this angle was 120 degrees. I mean, I told you, but you don't need to know that. Right, so let's start with sine. What I'm going to do is I'm going to copy the coordinate down so I don't have to keep scrolling up. And we're going to find all 6 trig functions of that angle. What's the angle? I wrote it as theta because we don't know what it is. Some mystery angle. But we have the location for it, and that's what we really need. Okay, so let's start with sine. Michael, what's the formula for sine?
X. Negative half. Negative 1/2.
So double check. Look back at your notes. When it says sine equals, what letter did we put there?
Y.
Y, I agree. It is a single letter, but this one is Y. So in this case, what's the Y?
Square root of 3 over 2.
Yep. And that's it. So that is the sine of some angle, which we don't need to know, represented by this coordinate. And again, you really know it because I told it, but you don't need to know. Okay, so the sine is the square root of 3 over 2. Right. How about Samantha? What was our formula for cosine? X. And what's the x in this case?
Negative 1/2.
Negative 1/2. Easiest 2 to do because you don't have any arithmetic. You just have to grab the numbers from the coordinate. All right. Let's look at our tangent. So Nick, what's the formula for tangent?
Y over X.
Y over x. So it's square root of 3 over 2 divided by negative 1/2. All right, so now we have a fraction over a fraction. We need to just clean that up a little bit. How do you divide a fraction by another fraction? Multiply it by the reciprocal. I'm just going to do it over here. So keep the top the same. Multiply by the reciprocal of the bottom. And what's going to cancel there? The 2's. So honestly, when I do a problem like this, I just go like this right away. If you divide 2 fractions that have the same denominator, the denominators are going to cancel. And all you're really left with is the square root of 3 divided by negative 1, which is exactly what we have here. So that's going to be negative square root of 3. So 2 goes into itself once, 2 goes into itself once. And here you're left with the square root of 3 times negative 1, which is negative square root of 3. Okay. Now, once you have the 3 on the left, all you have to do is take each one of them and do something with them to get the 3 on the right. What was the connection each time between the formulas? You just had to take this one and do what? Flip it. That's all you have to do. Take the one on the left and flip it, and you get the one on the right. So each time. So let's start with cosecant. How about Anna? Anna, right?
Yeah.
What's what do you get when you flip square root of 3 over 2?
2 over 3.
Okay. So 2 over square root of 3. So that is the cosecant of the angle in this problem represented by the coordinate I gave you. But what's the issue with leaving it as 2 over the square root of 3? Yeah.
Square root on bottom.
Square root's on the bottom. So this next part, this isn't trig, it's just arithmetic to fix the square root. Colby, can you remind me, how do we fix that square root in the bottom?
You would multiply it by square root of 3 on top and bottom.
Yep, perfect. So that's going to give me 2 times the square root of 3 in the top. And in the bottom, the square root of 3 times the square root of 3 is the square root of 9. But the square root of 9 is what? 3. So for the cosecant, that's what I would be looking for. And you don't do any of these out. You're not going to take like the square root of 3 on a calculator and then divide it by 2. No. You leave it exactly like that. Okay. Secant, that one's going to be a little bit nicer. All we have to do is flip the cosine. So Ariel, what do we get if I flip the cosine?
-2.
-2, you're done. If you're like, well, should I put -2 over 1? You can. You're not wrong if you do that, but you don't really need it. Okay. And now let's look at our cotangent. So look at the answer we got for tangent. And Jay, the answer we got for tangent, was it a fraction? Well, how about what we circled?
No.
No. So we don't have a fraction there to flip. But to get the cotangent, you have to flip something. So what could you do to make that a fraction so you could flip it? You could put it over 1. So if you put it over 1 and then you flipped it, what would your cotangent be? Yeah. It doesn't matter where you put the negative in a fraction. You can put it in the top, the bottom. I usually just keep it in the top. Okay. Same problem here that we had with cosecant. We have to fix it. Anyone think they can tell me what that would be when you fix it? You don't have to show me this step every time. If you can fix it in your head, that's fine. Okay.
-1 square root of 3 over 3.
Yep. And -1 times the square root of 3 is just square root of 3. So I'm just going to write it like that. Negative square root of 3 over 3. Right. On a test, that would be 6 separate problems. Any questions on that one? All right. So I gave you guys a coordinate to start. And again, I'm guessing 95% of people had no idea that that's the coordinate for 120 degrees. Now, here's another coordinate. I'm not telling you what angle that this coordinate represents. All I'm telling you is, here's a coordinate, and that's what you need. But I'm going to guess that more people are going to know what that is the coordinate for. The x value is √2 over 2, and the y value is √2 over 2. Anybody think they know what that is the coordinate for? Yeah? It is. It's the coordinate for a 45. Because think about, from the origin, you've gone that amount to the right, and you've gone that amount up. The amounts are the same. So if you go the same amount over and the same amount up, it basically puts you halfway between 0 and 9. Okay? If that doesn't make sense, you don't really have to worry about it. And the fact that it's 45 degrees, you don't even need to know that in this problem. All you need is the 6 formulas. Okay, but since x and y are the same, it's going to save us a little time for this problem. So let's start with the sign. Tyler, what's my sign here? And because they're the same, which one did you pick? The x or the y? The y. The y, yeah. When they're the same, if you make a mistake, well, you're lucky. But most of the time, they're not the same. How about Edma? What's my cosine? Yeah, it's also square root of 2 over 2 because the x is the same as the y. Right, and Ray, what's my formula for tangent?
1
y over x.
So we have to take the y value and divide by the x value, but the y and the x value are the same. So what would we get when we divide?
What would you give me?
Yeah, you divide the y and by the x.
You would get 1.
Yeah, you get 1. Doesn't matter how fancy of a thing in the top and how fancy of a thing in the bottom. If they're the same, when you divide them, you're going to get 1. So let's do our cotangent, because that one's quick. You can go in any order that you want here. So Ian, what would my cotangent be?
Would it be -1? Or
So once you have the one on the left, what do you always do with it to get the one on the right?
Wait, what are we doing? Cotangent?
Yeah, we're just doing the cotangent.
Would it still just be 1?
Right. How did you get that? What'd you do? Basically, just take this one and one word.
Divide it. Wait.
Not divided by 1. What do we do with the one on the left to get the one on the right? Yep. Flip. That's it. Just take it and flip. So when you flip 1, it stays as 1. There's 2 numbers that you can flip and they stay the same. When you flip 1, it stays as 1. You even know the other number? When you flip it, it stays the same. I'll leave you wondering. Maybe you'll figure it out. All right, let's look at the cosecant. So we have to get the cosecant. And we already have the sign. So Emma, what do I have to do with the sign to get my cosecant? Flip it. That's it. So when you flip that, even if it's not okay as a final answer, can you just tell me what you get when you flip it? 2 over square root of 2. And Dennis, what do I have to multiply by to fix that?
square root of 2 on top and bottom.
Square root of 2 on top and bottom. So it's going to give me 2 square root of 2 over the square root of 4, which is 2. And now, Sadie, what can I do here? Yeah, anything on the outside of the square root that's the same, I can cancel. So that turns into the square root of 2. All right, so Michael, based on that, we should be able to do the secant pretty quick.
Yeah.
What's my secant?
Square root of 2.
Because the cosine and sine were the same. Any questions on it? So both of those were the type where I give you a coordinate to start with. Okay, let's look at this one. Find the 6 trig functions for 90 degrees. Okay. What's different now this time? You weren't given a coordinate. The fact that they told you the 90 degrees, that doesn't really help you to do the problem. You have to find the coordinate so you know the x and the y. So if you have the coordinate memorized, you can just go from there. If not, make a diagram and figure out where 90 degrees would be. So Joe, when we draw 90 degrees, where is it on the circle? Right here? That's for 0.
Yeah. Well, then it's 90 straight up.
Straight up. So the coordinate for 90 degrees is straight up. So now we just need to translate straight up into a coordinate. I need to know what the x and the y would be. Kyle, what's the coordinate?
0, 1.
And now that you figured that out, this problem is exactly the same as the last two. Usually when you have to do a coordinate that involves 0, 90, 180, or 270, there's no square roots. So the arithmetic part is a little quicker. So Sam, what is my sign? 1. So the sine of a 90-degree angle is 1. Sheridan, what's my cosine?
0.
0. And Nick, the formula for tangent is what again?
Y over x.
Y over x. So basically, just look at the 2 you just wrote above it. 1 divided by 0. Y over x. And what would you get if you try to do 1 divided by 0? No, you don't get 0. Nope. Right. You can't take a number and divide by 0. A number divided by 0 spells no. No means you can't do it. A number divided by 0 doesn't work. So we write undefined. Undefined. I see. You cannot divide by 0. All right. How about Anna? What would be my cosecant?
X over y.
Yeah, you don't even need to think about it that way anymore, because once you have this one, all you have to do is take the one on the left and do what with it? Flip it. Yep, you don't even need to think about the formulas anymore once you get the 3 on the left. I mean, you can, but I would just think about that number and flip it. So what would your cosecant be?
0.
So if you wrote this number as a fraction, how would you write it?
Oh, 1 over 0. I don't know. I'm like really confused right now. I wasn't even paying attention to
That's okay, at least you're honest. So when we want to make a number a fraction, how do you make it a fraction? Put it over what? Put it over 1. So when you flip 1 over 1, what do you get? 1. So the cosecant is 1. All right. The secant. Ariel, what number do I have to flip? You don't have to tell me how to do it yet, but just tell me what I have to flip.
0.
I have to flip 0. Is 0 a fraction? No. How could you make it a fraction? You could put it over 1. So now, when you flip 0 over 1, what do you get? You get undefined. 0 over 1, when you flip it, is 1 over 0. Can't divide by 0. All right, so we've seen when you flip 0, you get undefined. How about when you flip undefined? What would you get? Get 0. Flip 0, you get undefined. Flip undefined, you get 0. And those are your 6 trig functions for 90 degrees. Any questions on them? So again, right there, you're looking at 6 separate questions on a test. You'll probably have maybe 10 or 12 of these kind of problems to do, but each one is going to be a different angle. I'm not going to give you one angle and have you do 6 things with the same angle. I'll give you 90, and I'll say, okay, find the sine. And then I'll give you one like 3 pi, and I'll say, okay, now do the cosine. All right, so this one, kind of like the last one, but what's a little bit different here? They've given you radians this time. Now, for someone that understands radians and can work in radians, it's not necessary to use degrees at all. Using degrees, if you do that, you're just doing that because you think that's easier. But that's not necessary at all. I think it's easier. Because the arithmetic is easier than you don't have a pi in it. So I think that's what we should do first. Change the radians to degrees, and then we can do it just like one of the other problems. So we've got 3 pi. Jade, remember what you multiply by to change radians to degrees?
180.
Yep, perfect. 180 over pi. Pi's are gone. And 3 times 180 is going to give me how much? Just think of 3 times 18. 3 times 20 would be 60. 3 times 18 is 54 with a 0, so 540. Okay, so that's better. I have an angle now that's in degrees, so I don't have to worry about radians. But I still don't like that angle. What do you think I don't like about 540 degrees? I'm trying to visualize where it is on a circle. It's more than 360. It's more than 360. It gets confusing to figure it out. So we want to do something to make it less than 360. Do you remember what we do? Subtract 360. Now, once I do this, it better come out to 0, 90, 180, or 270 because I haven't taught you how to find any other coordinate. Tomorrow you'll be able to, but not for today. So that is the same as 180. Okay, so now I finally have an angle that's in the units that I think are easy to work with, and it's small enough to work with it. What's the last thing I need to know about 180 before I can find the sine, the cosine, and the tangent? Yeah,
The coordinates.
I gotta get the coordinate. Once I have that, I'm good. Okay, honestly, off the top of my head, I know the coordinate. But if I don't, I'm going to make that little diagram and just kind of figure out what the coordinate is. Where's 180 on the circle?
Cross through 0.
Can you describe how to get there?
You go halfway around the circle.
So it's halfway around the circle, right? So it's to the left. If you're looking at the origin, it's to the left. And what's the coordinate of the point when you go left?
-1.
Yep. So that's your x. And your y is? 0. Yep. Okay. So this time I'm only finding the sine, the cosine, and the tangent. Okay, just the first three. So let's start with our sine. Johanna, what's my sine here? So sine is the y value, which is 0. Tyler, what's my cosine? Yep, it's my x. And my tangent is y divided by x. So the shortcut is just look at the two numbers you just did and divide them. 0 divided by -1. What is 0 divided by -1? Undefined is when you have a number on top divided by 0. So number divided by 0 spells no, you can't do it. This is 0 divided by a number. This is undefined, but it's flipped. So what did we get in the last one when you have 0 over -1? There you go. 0. 0 divided by -1 gives you 0. Any question on that one? Okay, so last one, I'm going to let you guys try it. Okay, I'll walk around and kind of point you in the right direction if you get stuck. But I want you to find the 6 trig functions of 11 pi over 2. So keep in mind, you only know how to find the coordinate right now if it comes out to 0s and 1s. So somehow, that's going to come out to a coordinate with 0s and 1s. Okay. All right, so let's take a look and finish this one up. So in terms of what you're going to have to do in this one, it's pretty much exactly the same steps as the last one. What's the first thing you would want to do with the 11 pi over 2? Yep, change to degrees. And what did you multiply by to do that? Yep. So that's going to cancel the pi's. And if you reduce 2 into 180, you're going to make this problem a lot easier to do in your head. 2 goes into itself once. And how many times does 2 go into 180? 90. So now all we're left with is 11. If you want to think of it as 11 times 9, and then just add a 0. So what's 11 times 90? 990. So this doesn't always happen when you change radians to degrees, but it's happened to us twice. We got an angle that's too big. So what are we going to do with 990? Yeah, and this time you're going to have to do it a couple times. So if you subtract 360 a couple times, you're going to get 270. Now don't do it a third time, because now you're negative, you went too far. Okay? Just stop at 270. Now, at this step, you don't want to say 270 equals this coordinate. That's not really true. They're different things. 270 is how far you go around the circle, and the coordinate is how you get there. Okay? So the coordinate for 270 is, what is that one?
0, negative.
Yep, 0, negative 1. And then you can go through all 6 trig functions. So your sine, your cosine, your tangent. Once you get that coordinate, finding the 6 should be, after a while, pretty quick. And then your cosecant is negative 1. Maybe now we know which number you can flip besides 1, and it stays the same. So we got that. What about my secant? What's going to happen there? Undefined. And my cotangent? 0. So that's the first part of unit circle trig. Tomorrow we'll look at what if your angle isn't a 0, 90, 180, or 270? How do you get the coordinate? So that'll be for tomorrow. Okay, so homework in the book. I think tomorrow night's homework is a worksheet. So if you are not here tomorrow, I'll try to remember to put the worksheet in the video. But yeah, tomorrow you won't need your book anymore. Okay, so it's 11 to 27 odd. And also I want you to do number 22.